Okay, I'm back again. Now let me check the settings that the app did not change it again. Okay, so the output it is at 1080p right now. Any feedback, is that any better to read on your screens? I guess it should be better because I think it should be output in full HD now. Maybe let's check Twitch on our second monitor. Okay, yeah, this is much better than yesterday. Great. Yeah, perfect. Okay. Then let's recap for a second. Let's open the node again. And let's start our application just so that we can get an overview about what we did yesterday. So, as we already said yesterday, we are going to build a data grid library for the Solid Hackathon. We're going to build that library in about 5 days. And yesterday was day one, where we started with defining some goals and some non-goals. Where we said, okay, we want lots and lots of data within our grid. We wanted to stay responsive for user input, and we listed some of the features, most notably grouping and filters, so that we can really gain insight into our data very, very quickly. We already started yesterday with some implementations. We generated some dummy data. Here's some dummy persons. There we have the seed. Maybe if I change the seed, then we can see that we have totally different users with names, basketball teams, I think, countries, and date of births. So just so that we have a bit of dummy data that we can display in our grid application. We then already have developed a first prototype, a first version of our virtualized grid. So we wanted to build a baseline library, a low-level library that is just concerned with rendering a grid of data without any knowledge about real column definitions or groups or filters, stuff like that. It's just there to render a grid of data in a performant way and only render what fits on the screen. So right now we are rendering, I think, 10,000 rows. Let's check. Yeah, we are rendering 10,000 rows, but if we check out the HTML, then we can see, maybe if we decrease the size a bit more. Let's do like that. Then we can see that we are only rendering the elements that are currently on screen, the cells that are currently on screen, and nothing else. And only when we start to scroll, then we can see down here in the DOM that we add the new elements that are then visible in the user interface. Currently, we are positioning every cell absolutely within the grid, but that has to be changed when we introduce those frozen areas, which we will do in the next step. But before we are going to start with the implementation, as soon as I stopped the stream yesterday, I noticed that we did not even initialize a Git repository here, so we don't have any history. So this is definitely the first thing that I'm going to do right now. So just saying git init. And let's see, we need some base git ignore. We have node modules. We have the dist folder for the build code. I want to commit the settings and the tasks as well. But I think we don't need anything else on git ignore for now. So maybe now let's just add everything. Implement first version of virtualized grid, and then we can be a bit more cautious with our commit messages and our commits, that we make a bit some smaller commits, so that our history is a bit more informative. Okay, as we finished with yesterday, we are able to virtualize the scrolling in our grid, but we want to be able to have frozen rows up here for the column headers, for example. We want to have frozen columns for maybe actions, I don't know. And we want to have the same thing on the end, on the right and on the bottom, so that we have in total 9 areas for the top left, the left one, bottom left, etc. Where we will be able to render data and scroll around in the data that we want to be able to scroll around in. Before we are going to get started, let's just improve the UI a bit, just so that we can get a better feeling for our application. Let's add a column width here for the person ID. No. Let's say we have the ID is quite short. Maybe let's only define 80 pixels. Then we want the name of the person. This is definitely something a bit larger. Same with the basketball team. Country can maybe be a bit smaller. And the date of birth is as well quite small. And now in our column width function, we can just say, I think I get the column in here. Yeah, perfect. So let's just do it like that. We can remove this on click here. So then we can just freeze the first column and the first row, just to get a bit of a feel, to see if it is working. And maybe let's increase the size of these columns here. And let's maybe add an action column that we can freeze to the end. And we just maybe add a pencil. Is there a pencil emoji? Whoops. Yeah, like that. So then we can pull the edit button to the right. Let's increase the size of that one a bit more. Yeah, perfect. Now we can see that we are scrolling, and then we can work on freezing the first column, the last column, and maybe the first and the last row, just so we can get a feel for that. Okay, so first let's think about the interface. So the first thing that I thought about was to just add a frozen row count, where we can say the first row is frozen. But now then we need to add a direction to this. Frozen areas maybe, and then we could say top 1, left 1, bottom 1, right 1. So that we definitely have defined where our frozen stuff is located at the moment. Yeah, I think I like that interface best for now, frozen areas. areas is an object, but is an optional object with optional fields, number, left, number, bottom, number, and right. Number. Let's maybe change the order to be in the same order as the CSS properties, top, right, bottom, left. And now we can determine how many rows are, how many rows and columns are frozen. What we want to do now is I think we are going to start with the separate areas for the scrolling. We peeked at the implementation of the AG-Grid library, just to see how they are doing it. My first intuition yesterday was that we would be rendering, oh no, I spilled my tea, that we will be rendering 9 areas, so 9 divs in here, and each div will allow the user to scroll. And we will just synchronize all those areas by setting scroll top and scroll right and stuff like that. But I think that we are going to do that differently right now. Because AG-Grid did it in a way where they have just 3 columns for the frozen left, the middle part, and the frozen right elements. And they are rendering the top elements completely separately. That way, the vertical scrolling can just be a scrolling where we don't have to synchronize the left and the right part, but we only have one element that is scrolling across the complete height, which is, I think, which might be optimal for scrolling performance. So this is something that we are going to try as well. So maybe we now have our row descriptors, column and column descriptors. So maybe let's add new areas for the frozen columns. Left frozen column descriptors. And this will just be column descriptors dot slice props dot frozen areas dot left on or 0. And the same thing we are going to do with the unfrozen column descriptors. No, I always forget if slice gets the start index and the end index. Okay, perfect. So we are just saying we want the frozen areas +1. No, this is not correct. Oh, no, that's not right. We want to slice from 0 to the amount of columns that we want to have frozen. So now that's correct. And then we can add the +1 here. Do we need the brackets here? Let's add the brackets to have this. Oh no, what did I do? In here. Like that, but here we need starting from index 0 to index how many frozen columns we have. And then we can start from that index and go to frozen areas. Oh no. Oh, let's maybe add variables for that. Sorry. Frozen column index. Frozen areas dot left or 0. First unfrozen column index, and we have a const last unfrozen index. If we have a 0, then we have to add a +1 here. Is that right? No, that's correct, like that. The first unfrozen column, if we have no frozen areas, then the first unfrozen column will be index 0. So that is correct. If we have one frozen column, then the first unfrozen will be index 1. That's correct. Okay. And the last unfrozen will be props.columns.length. And then we have to remove the props.frozen areas.left. How many are frozen on the left? And we want to remove props.frozen areas.right, like that. And then we need brackets, I think, around that. Like that. Now I still have a syntax error somewhere. Where is it? I need more space. Here. Perfect. Just a second. Okay, so we have our frozen. We have to remove the left ones. We have to remove the right ones. Do we need +1 there? No, wait, we were here. Here we have the last frozen column and the first one. Let's just check if this is correct. Let's say we have column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have one frozen column here, one frozen column here. So it's 10. So the last index of an unfrozen column is the 8. So 10 minus 1 on the left, minus 1 on the right. Index 8 remaining. Perfect. Okay, so now we have the columns. So we can use that for first unfrozen column, like that. Then we can do it here like that, starting from the first unfrozen column index, going up to the last unfrozen column index +1. And now only thing remaining are the right frozen column descriptors. Where we will just do that, the last frozen +1, all the way to the end. Let's see if this is working as intended. Unfrozen. And the right frozen columns. Like that. Now we want to check if this is working. So when we don't have any frozen columns, We have 0 column descriptors for the left area. We have 6 column descriptors for the middle area and 0 for the right. Let's check that again by saving this file so that we have 1 on the left, 1 on the right. And now we have 1 on the left with, okay, I'd like to call that function. Yeah, with index 0. We have 4 in the middle and 1 on the right. Okay, great. So now let's remove that console log for now. Wait, why am I building cells on scroll now? This is not good. Oh no, it's perfect. It's fine. Of course, because when I'm rendering a new cell, then I need to render those new cells. Everything all right. Everything working as intended. Okay, so now let's change up our rendering. So we have our grid container with its proper size, and we want to remove the scrolling stuff. That was not correct like that. Because now we are no longer scrolling on the whole grid container. Yeah, so the event listener is now destroyed. But we want to have the different columns. We can add that in a... No, let's do that later. Let's just add the class name just to have a marker some kind. So this will be within our grid container. These will be the... so we have an area for all our body elements. So the middle unfrozen rows, an unfrozen row container. Unfrozen row container. And within that unfrozen row container, we have 3 columns for the frozen columns on the left, the unfrozen columns, and on the right. Frozen column container. Then we have unfrozen column container. Maybe we have a left frozen column container and a right frozen column container. And let's remove that code for now. And let's remove that just to start from scratch. So like that, left, middle, right. And of course now we have to align them from left to right. Not quite sure if we will be doing this using just the layout algorithm. So we have a set width on the first element. We start it as inline block. So they are just placed next to each other. Or if we want to use flexbox, I'm not really sure about the performance comparison between flexbox and the flow layout. Unfrozen rows. Let's just add the S here. Left frozen columns, unfrozen columns, and right frozen columns. And let's do like that. Display flex, align items, flex start. But we want overflow Y. Scroll, call flow x. I always forget which combinations of y and x are allowed and which are not allowed. Unfrozen rows container. No, that dot is wrong. Okay, now we have them next to each other. This is okay. So now we need to calculate the width of the different areas. This will be easy. Width of left frozen columns is equal to, I think we will use a create memo there. And we will be adding a sum by function, which might come in handy. Items read-only array D by item D number. Like that, and now we have a sum by function that we can use here, where we will be summing with the left frozen column descriptors. Where do I get the column width? Whoops, that was wrong. Yeah, column dimensions. Like that, and now we can do dimensions d.index. Oh no, it's much easier. We don't need to sum that. We can just use the first and the last one. Yeah, that's much better. We are going to use the first one and the last one and directly calculate those values. That's much better. So we have first is column dimensions. We can just do it like that, right? If props dot frozen areas dot left return 0, let's do it like that. Then we have the first column, which will be which has a start pixel value, a width value, and we have column dimensions with props dot frozen areas dot left. When we have two columns, then we are going to take the second to last and use the end property there from 2, and now we can just return to minus from. And now we have the width of the frozen columns on the left. Now we're going to do the same thing on the right. Width of right frozen columns. where we are going to use I have that somewhere, right? Last unfrozen column index. This is what we want. We are taking the last unfrozen column index, but we need to add +1 there. And this is our start. And our end is props.columns.length -1. So we have the last column, and there we take the end and return the value. Perfect. And now we have width of unfrozen columns. This should be easy because we can just say props.width minus width of left minus width of right. And this would be our width of the unfrozen columns. Perfect. Oh, now I have my orders all mixed up. So we definitely have to move some of that code out of that file. So maybe let's move our frozen column stuff. Row descriptors, column dimensions, last column dimension. Let's do it like that. Frozen rows, frozen columns stuff. Okay, now we have our frozen columns, and now we can use that to set the dimensions of these things, where we can just say width is width of left frozen columns plus pixel. And the same thing will be done in the middle. And for the end, and now we have our left, middle, and right. Perfect. Okay, now we need to set the height correctly. And the height is calculated the same way as we did with the columns, only for the rows. Now I'm thinking if this is something that's worth pulling out so that we can just take the same code. Let's just copy that for now. Like that. And now let's try to replace all occurrences of column within that block with row. Now we need the lowercase stuff. Like that. Frozen columns, frozen rows here. Now we're doing the top, last unfrozen row index, row length, top and bottom. Now we have top frozen rows, top frozen rows. Now there we are taking the row descriptors, of course. And then we have the top frozen rows, frozen areas top, and row dimensions. Row dimensions top. Width of frozen rows should be height of frozen rows. Height of bottom frozen rows, yeah, that's right. Then we take the bottom here from row dimensions, last unfrozen row index, that's correct. Start to row dimensions all the way to end. Again, we have height of unfrozen rows, props dot height. Height of top frozen rows, bottom frozen rows. Like that. And now we have unfrozen row descriptors, so you just say row, first unfrozen row, last unfrozen row, height of unfrozen rows, right frozen rows. Wait, is there something missing? We have the unfrozen column descriptors, we have the right frozen column descriptors, the left column are missing. Left frozen column descriptors. Are they missing? Oh no, they're not missing. They're all the way up top here. Like that. That means this can be moved down as well. Top frozen rows, unfrozen rows, bottom frozen rows. And now we can use that for height. And inside of our unfrozen rows, the left frozen rows, here we will be using the height of unfrozen rows plus pixel. And we will be using that everywhere here. No, this is not correct. No, this is correct. It's okay. Can I read properties of undefined reading start? Line 171. Is that the correct? Yeah, 171. This is interesting. So we have a render where we don't have row dimensions yet, because we don't have rows. If props.rows.length return 0. Same thing here. And same thing for the columns when those are not present yet. Like that. Next try. Inspect. So they have the same heights, definitely, but the heights are not correct. And the heights are depending on the available size. No, that's not correct. Let's see where we set the height of unfrozen rows. There we're taking props.height. No, that's correct. Yeah, that's correct. No. We have, so far, this is the height of the container for the unfrozen rows. But we need that on, we need that one here. Style like that. And here, so this is not correct. This is the height of unfrozen row container. And same thing with the width of the unfrozen column container as well. So now we need the width of all unfrozen columns. Yeah, we just need that. Unfrozen columns. This might be an expensive more expensive calculation. So in here we could iterate through all unfrozen columns via the column descriptors, but I think we are just going to do it like that. So we have the column dimension last unfrozen one. So we have the first unfrozen column index is the start value. The end value is last unfrozen column index. And there we're taking the end value, and then we can just subtract that and have the width of our frozen columns. And now the same thing for the rows. Let's do it here. Like that. And now we can, down here, we are taking the height of unfrozen rows, and here we need the height of unfrozen row container. That's better. So now we have our container for the unfrozen rows, where we have frozen rows at the bottom, frozen rows at the top. This container contains the columns for the so these need so wait, why are we even flexing here? So the width is somehow not correctly calculated. With the width of unfrozen columns. Again, this should be the width of unfrozen column. Yeah, that's the width of unfrozen column container. That's the arrow. And now let's see if our values match. They're still a bit chopped off because of the scroll bar. This might be a problem, because when I say the element should be 80 pixels wide, then it should be 80 pixels wide. So maybe we will just for now let the scroll bar cut away space from the last cell. Or we are going to measure the width of the scroll bar to remove that from the width. But we will just leave that for now as is, but we are going to stop them from shrinking, right? Frozen columns container. And we have the unfrozen columns container, like that. Yeah, now we have 80, 612, and 50, and this one is overlapping a bit to the right. Yeah, that's okay. Okay, so now we have our columns for the elements. Why is it again too small? My styles are not coming. Left frozen columns container, left frozen columns container. Why is that not working? Now it's working again. Why wasn't this working right now? So is that working when we change the size? Yeah, that is working. Yeah, now it's working. Weird. Yeah, the flex here in your auto is also coming in. So this is okay. And now we need, what do we need to do now? This seems to be working just fine. Now we could start with rendering the content, or we could first work our way so that we have a scroll bar in here. So in here, in our unfrozen columns, there we need our absolutely positioned cells, and we need this spacer thing right here. Oh no, that was not correct. Here we need the spacer. And we need this to be the width of unfrozen columns. And the height, I think the height is irrelevant. Let's just say 100%. Oops. But we need that to be overflow x scroll and overflow y hidden. I think it will be cursed to visible. So this is not working yet. Oh, because the overflow is in the wrong place. It needs to be here. So it is working, but the scroll bar's all the way at the bottom. Damn it. So the scroll bar is all the way down here at the end of the frozen area. How can we make that work? So here we have the same problem. Interesting. The scroll bar is added manually there. This is interesting. Yeah, so this is just placed above it. And that one has, I guess, overflow hidden. That one is overflowing. Yeah, it's definitely overflowing. It's also used for the vertical scroll bar. Okay, right. Yeah, and overflow left right is hidden. And then they're setting scroll left right on that element, I guess. Store as global variable. dm1 dot scroll left. No, they are not. So which element is... Okay, of course the pinned columns are not pinned right columns, center columns. Is that one scrolling? No, that one is also not scrolling. This is interesting. So now what I would have to do is I need to add another scroll bar down here. Just so that we have a scroll area, but I think it's looking a bit better when the scroll bar is across the whole size of the app, even with the pinned columns. Pinning. Yeah, I think it's cool when you also can scroll on the right part, and the scroll bar is moving all the way from left to right, because right now here it's cut off anyway, so the scroll bar can also go all the way to the left and the right. And then you can also use your mouse all the way on the left, on the right. So maybe let's do that. That means So we could just have these 9 areas where only 1, 2, 3, 4, 5 are scrolling anyhow, and we synchronize those 5 areas. And then we could just use the default browser scroll bar. But then we have multiple inputs right here also for the scroll, because users can scroll on that scroll bar that only scrolls in the HTML element for the dummy scroll bar. So that needs to synchronize with the grid. Then we have that scroll bar, which scrolls this whole container. And the header is manually synchronized anyhow. So let's rethink that again. Let's first add back our scroll bars with the dummy container. Can we do that? When we do that, we lose the positioning. So when we scroll, we cannot build fixed elements, because when we scroll, those absolutely positioned elements will scroll away as well. As expected, this is a very tricky problem. I could just add an overlay for the scroll bars. Where then could do pointer events or an underlay, so to say. Yeah, let's do that. And then I can use this to measure the size of the scroll bar as well. This might be good. Scroll bar dummy. Like that. And this scroll bar dummy is width 100%, height 100%, overflow. Scroll in both directions. Yeah, now we have the global scroll bars around our grid. I kind of like that. Yeah, like that. Then we need to measure the size without the grid. Let's see, can I just say scroll bar dummy HTML div element, oops, like that. And now we can, let's just log that out for now. Create event console.log scroll bar dummy dimensions, like that. And now this is delayed, right? like that. And now I just didn't attach the ref, right? Yeah, let's revert that. I just forgot to attach the ref element. Okay, so now we have these dimensions. And now let's hope that these dimensions are without the scroll bar, but I kinda doubt it. No, they are without the scroll bar. Cool, perfect. So now I have this is great. So now instead of using props.width and props.height, we are just using the scroll bar dummy dimensions. Grid dimensions. Let's use those. Props.height. Like that. Props.width. When I'm measuring anyhow. Yeah, no, okay. And this will be a grid dimensions dot width. And I killed it. What? I know, because the scroll bar dummy, no, this is sized 100%. It's the wrapper element, the wrapper div itself. This one needs props.width and props.height. Yeah, no, okay. So now we have our scroll container inside of our grid. And this does not affect. So now we can use that one. Oh, we have a question. Couldn't you just split the screen into 9 areas? Shown by the bottom edge and right edge. So what I'm trying right now is I'm trying to synchronize the scrolling, but I just tried it with an approach where I had 3 columns and 3 large columns. So they just span the whole the complete height of all rows. This led me to automatically have a correct vertical scroll bar, but the horizontal scroll bar would then be all the way at the bottom of this scroll container, because only the middle column would overflow. So what I'm trying right now is I'm building this background right here for the scroll canvas, so to say. And on top of that, not within, on top, I'm rendering my 9 areas where I'm synchronizing the 5 areas that move on scroll. So more or less exactly the approach that you are suggesting. So I will just synchronize the scroll positions of these areas. But I'm not sure if I am going to be using on scroll or if I'm going to be using request animation frames. And I'm not sure. Let's try this. Let's add this dummy content. Grid dimensions dot width pixels. And background yellow. Now we have our content. Yeah, because right now when I'm scrolling here, the mouse events or the touch events are not propagated to the background properly. I can even click back here. I don't think this is working. And the problem is that I have to propagate the scroll events from the whole grid. So when I'm scrolling here up and down, I only need, because in your approach, if I got that correctly, the right column will lead to the right scroll bar, and the bottom fixed row and the bottom in the middle column will lead to the horizontal scroll bar. Which means when I'm scrolling in the middle area, then I have to propagate the scroll event anyhow. But I'm not quite sure why this isn't working right now. Because I'm not having position absolute. Here, position absolute. Like that. Yeah, now it's blocking the scroll event as well. So here on the scroll bar itself, there I can scroll, but I cannot scroll on the main area. Propagate scroll. So I want to propagate the. I'm not quite sure what kind of events that is. I think it's the wheel event, right? dx, I think delta x. Yeah, that's right. So I could take that wheel event and scroll bar dummy, dispatch event. The event is already being dispatched. Damn it. I think this is not working. Redirect wheel event to other element. Yeah, so they are just using and that will only be also only be working with mouse wheel and not with touch events. Of course, I'm not really aiming to support touch devices, but this seems to be such a small thing to lock them out of that. Yeah, so they're just using the wheel and using that to scroll. I could do that as well, because I already have a signal for the scroll position. So I could just use that. and use the wheel event on here. No, on our main element, on our content block. Yeah, I don't really want to use the wheel event. I don't like that. So this one won't receive an on-scroll event because it's not scrolling, right? Yeah, exactly. What if I do overflow auto? No, same thing, no scroll event there. How am I going to do that? I really don't want to use the wheel event, because that would mean that touch events would not work there all of a sudden. And in this AG grid here, you can also don't scroll. You can scroll vertically within these columns, but you cannot scroll horizontally in here, which I don't really fancy so far. I think in our previous implementations, we just used the wheel event and caught the wheel event on this element and just set the state for the scroll bars. Which would work as well, of course. Let's try that. So maybe let's just do it like that. Old scroll top is scroll bar dummy. No. Delta y. Left delta x. And now this should. Ew, and now I have to do prevent default. Yeah, now this works. So the scroll bar is moving when I'm moving my touchpad. I don't get any flow behavior, but that's, I think, not really a problem. I guess they don't have that as well. Yeah. So now I can redirect that. I cannot. I also can scroll on here. The question is that triggering the on scroll event on this element? Yeah, it does. Okay, cool. So now I can just use that one to feed my signals. Set scroll top, target scroll top. Set scroll left, target scroll left. Like that. Where I have all my console logs. Let's try that. Yeah, perfect. I'm all the way at the bottom. This is working so far. And now I can re-add my my areas. The font looks odd. Yeah, you think so? Think so? My favorite letter in this cursive font is the F. I think I really dig that. Do you have anything here? Scroll left. And so I really like that cursive font. I think this font is really no longer existing officially. Here it's Dank Mono. I can really recommend that. I kind of like it. I bought that with a student discount. Okay, so now let's get back to our content. Now we don't have touch support, but I guess we can later try to re-implement that. But so far only the mouse wheel or the touchpad, of course. Yeah, it's still working good. Okay. And now let's try to re-add our areas. I could just simply statically render 9 areas. I think we are going to do that. Or are we going to do... No, I think we're going to do 9 areas. I think that's fine for now. So let's try that. The naming will be kind of ugly, I guess. So at first we have the unfrozen rows, unfrozen columns container, and all combinations of those, is that right? Of course we have, oh no, we have the left frozen rows and let's say start frozen rows and start frozen columns container. Top left. Then on the middle on the left we have the unfrozen rows, but the start frozen columns. And then we have the end frozen rows and start frozen column. This is bottom left. So now we have, instead of the start frozen columns, we have the unfrozen columns. And then we have the right elements. Oh no, end frozen, of course. Like that. Okay, the formatting is so beautiful. And now we have to position all of them absolutely. But this is not a problem. This should be quite easy. Here, style, position, absolute. Top 0, left 0 pixels. Width is the width of left frozen columns plus pixels. And the height is the height of top frozen rows plus pixels. Okay, next one. The top value is height of top frozen rows. The height is the height of unfrozen row container. Width is the same thing. Same thing on the bottom. So top is I don't have that one right now, I guess. Have I? No. You know what? We're just going to do bottom 0. And we're going to do width is still that one and height of bottom frozen rows. Okay. Now let's do the same thing for the middle ones. Top center. The left value is exactly that one. And this should be the width of unfrozen columns container. And height of top frozen rows. Yeah, that's okay. Next we have the unfrozen rows, the center. Left will be width of left frozen columns, that's right. The width is width of unfrozen columns, that's right. The top will be height of top frozen rows plus pixel. And the height is height of unfrozen row container. That's okay. Not really sure if this is the smartest approach to write that. I have a dangling feeling that this might be improvable. Okay, so bottom center. The top value, we will just do bottom 0 again. Left will be width of left row column, that's correct. Width is correct. And the height is height of bottom frozen rows. Only 3 more remaining. Top right will be right 0. This is easy. Oh no, right 0 is not correct, I think, because this is not including the scroll bar. But we will see. This should be fixable quite easily. So we have the width of the end is the width of right frozen columns, and the height is height of top frozen rows. Now mid right, this is not correct, top 0. Top is height of top frozen rows, right 0, width is okay, and height is height of container. And the bottom right is bottom 0, right 0. and the height of bottom frozen rows. Okay, this is looking not too bad. Now let's remove the we have to move that in here. Ah, perfect. So then we also don't have any problems with the scroll container. Perfect. So we're just going to move that. Inside of our content. Let's add a class for that. Cell area container. Okay, so now we only have one dangling scroll bar here. But other than that, the positioning seems to be working. Okay. So now why do we have a scroll bar right here? So we could just do overflow. No, not on that one. Ah, because I had overflow auto. Yeah, perfect. Ah, now this really is overlapping, right? Is it? No, it's not. This is just too large. Okay, cool. So now I have my 9 areas. Can I just use Flexbox? I could use a CSS grid. Most definitely. Yeah, I can just use a CSS grid right here. And then I only need to calculate width and height. Which should not really be changing. Which would mean that when I adjust the width of a column, then the Flexbox has to recalculate the positioning. Right now with the absolute positioning, this is all set in stone. I think I will leave the absolute positioning for now. But this might be viable to improve later. So that we could just lay out these elements with Flexbox or CSS grid or whatever. And not position them absolutely. It would make this a bit easier to read because I could remove position absolute top and left from all of those and would only need the width and the height of the elements. And I would have to change the order, I guess. Yeah, right. You know what? Let's do that. I think this is cool. Now the only thing is, what do we want to use? So we could use a Flexbox and have them wrap around with flex wrap. This will work. I could just use inline elements. You know what? Let's add a style right here. Dash container. Let's add another class, grid area. We forgot our low dashes right there. Like that. Like that. Now we can say each grid area is display inline block. And now we can just remove top left, here position, bottom left, position top left, position top left. Make a cool multi-cursor edit, top left, top left, top right, top right, top right. Remove that. Where am I? Remove that and remove that. Oh, I miswrote here that. Now I need a vertical aligned top. So that is obsolete, I guess. Unfrozen rows container. This is obsolete, I guess. Where do I need the alignment? On the cell area container. Vertical align top, I think. No. Oh, I need that on the. Do I need that on that one? Yeah, I need that on that one. Okay. Now we have top left. The order is now incorrect. Top left, top center is next. Oops. Now the top right. Now the mid left, mid center, and mid right. And bottom left, bottom center, bottom right. Top right, mid left, mid center, mid right, bottom left, bottom center, bottom right. Perfect. Much better. That was a good idea, thanks. Okay, now we have our grid areas, and now I have to set those to be able to scroll. So we have our grid area will be overflow hidden, and then we can set scroll top and scroll left on these elements. So I need refs for all of these areas. I need refs for all 5 areas that I want to that I need to synchronize. So we have the, oh god, I have the start frozen columns, unfrozen rows area. Then we have the unfrozen columns and start frozen rows area. I have the unfrozen columns and the unfrozen rows area. And I have the I have the unfrozen columns and frozen rows. And I have that one, but with the end frozen columns. And now I can synchronize them. Create effect. No, let's do is create render effect. Like that. Now the left element needs to be synchronized with scroll top. The top middle unrosen needs to be synchronized with scroll left. The middle needs both. The bottom one needs that, and the right one needs that. And now they should be synchronized, which is of course not working because there's no content, so it's not overflowing, so scroll top is not working. But now I can render the content. But first we're rendering the dummy content, the placeholders, because every area needs a placeholder. Every scrollable area needs a placeholder where the virtualization is going to happen. So the top center needs the placeholder. Which will just be a div where we're going to say, is kind of similar to that one, but not the column container, but the width of the unfrozen columns. Okay, this is not yet working. Why not? Wait, the content is missing. Cannot set properties of undefined. Okay, that is valid. Yeah. Oh no, I did not set the refs yet. That's the problem. So top center. No, we started on the left. Ah, damn it. Mid left. Ref. No, I used the classes the other way around. Am I using those classes yet? No, I don't think I'm even using them. But I want them to be. I want to have the classes to identify them in the UI. So mid left, top center needs a ref as well. Oops. And this is unfrozen columns, start frozen rows area. Top right doesn't need one, mid left needs one, mid center needs one. Unfrozen. Mid right needs one. And frozen column. And bottom center needs a ref. Unfrozen columns and frozen rows area. Okay. And now, because we did a render effect, we don't have the values present already. Where is it? Where is it? Oops. Like that. Yeah, and now this one's already working. The top one. Why only the top one? Because I only specified the dummy content for the top one. Oh god. I think we should abstract these areas later. I'm not quite sure if this is worth it. Okay, mid left. Now needs content as well. Width of unfrozen column. No, that's not right. Width of left frozen columns and height of unfrozen rows. Now mid left should be synchronized. Yeah, and that is working. Cool. Now let's sync up mid center. And mid right. And bottom center. Like that. That's looking good so far. And now we need to add the content to each of those areas. And this will be basically this one. So we can remove that. Okay, let's start with the top left area. What are we going to do? Oh no, oh no. I need to recalculate the dimensions. Because the absolute positioning should always be relative to their container. Otherwise, they will know what will happen then. If these elements are specified relative to this corner and I'm scrolling, I think this could just be working. Because the grid area are not position anything, so they will be ignored. So that one will be the reference for our cells. So this might actually still be working. Let's see. Let's start with mid-center. I think this is the most interesting part, where we want to render our content. So here, what are we going to do? We are going to, let's just add these two loops here. And we are not, oh no, we don't have the visible rows yet. The calculation of visible stuff. Wait. So the visible rows, size of visible area. So this is not correct. This should be the, so row, yeah, that's correct. The items will be the unfrozen rows, row descriptors. And size of visible area is height of unfrozen row container, like that. And the start of the visible area will be scroll top, I think. This might be working. Visible unfrozen row descriptors. Okay, visible unfrozen column descriptors will be, items are the unfrozen column descriptors. The size of the visible area is the width of unfrozen column container. And scroll left is the start of the visible area. Okay, this might actually be working. Now we can take this double loop here, go to the mid-center, add some imports, visible unfrozen rows, visible unfrozen columns, so the virtualization is working, but the absolute positioning is not working because I need to add to these values, to left and width and height. I need to add I need to remove the unfrozen the stuff on the left here and at the top. Yeah, I just need to do that. Yeah, the left and the top needs to be changed. Oh God. You know what? Before we are going to do that, let's what? Let's add a separate component for these grid areas, I think. Is that worthwhile? Yeah, I think I should do that. Let's do that in the same file. So each grid area. Let's start with the middle one here. So we need a ref like that. I'm not quite sure if this ref thing works across the boundaries of components, but I think it should be working. Then we need a label. We need a width and a height. And we need a content width that may or may not divert from that. Because for the frozen, for example, for this, the content is the same thing as the width itself. Probs on width, probs on height. Where are my row descriptors? Yeah, they have a generic, so I have this t-row stuff right here again. I have mutable. Whoops. Do you have already a type for that row descriptors shenanigans stuff? No, I don't. Yeah, let's add it. Let's add it at the bottom, I think. Like that, and now we have our grid area here where we have the row descriptors, usable column descriptors, list of column descriptors. We need the tcolumn generic. Props dot visible rows. Props dot visible columns. We need the column dimensions and the row dimensions, which is a list of those time range stuffies. Props dot row dimensions. Index, accessor number. Oh. Like that. And we need a render function for the cell. Like that. Okay, what else? Tcolumn. Yeah. Like that. And we need the props.content width. And props.content height. But now we only also need an offset. Offset left number, offset right number, because this area is placed somewhere within this grid, and we need this calculation to revert the offsets of the columns. Because the columns, this column, for example, has a start in the column dimensions. This has a start, a width, and an end, and start and end are relative to the top left corner of the grid itself and not of this grid area. So we need to we need to include that in our calculation. Minus props dot offset left, and of course offset top and not right. Okay. And now we can render our grid area, and we'll do that in here. Let's start with the ref. We need a label, which will just be that class name. Cell is easy. Props.cell. Is it? Like that. So we just need to add the generics because we don't have anything right now. Maybe you can remove it in the end again to specify those generics. Oh, let's get the easy stuff all of the way first. Column dimensions, column dimensions, row dimensions. Maybe we are going to add that to an object later. Visible column descriptors, visible unfrozen column descriptors, visible row descriptors, visible unfrozen row descriptors. Okay, now the rest is specific to the area. Maybe let's add the label at the top. Oops. Here. So let's start with the width. This is easy, this is that. The height is that. The content width and content height are those two. Content width, content height. And the offset left is the width of left frozen columns. And the offset top is height of top frozen rows. Like that. Okay. Because now I rendered it twice, the middle part. Oh no. And now my rev is not working again. Let's take a look at the playground. I'm not quite sure how refs are working across component boundaries because refs are compiled a bit weird. Button, HTML button element, ref button. Let's take a look at the output. And there we can see that the ref is just pulled into another variable. We have this left button from line 7 here. Can zoom in a bit more, I guess. And we are assigning the button with the element directly on clone, so before any effect is run. So this should be working already. But now what happens across component boundaries? Now what's happening here? So we create a component with ref filled as a function, so it's already compiled to a function. And this function is called with elements. So our ref should be all set up, I think. Why isn't it? Where's my grid area? Here. Unrolled columns, unrolled rows area. Unrolled columns, unrolled rows. Yeah, the ref is not set up. So this is undefined. Wait. Oh no, I think it's just a prop. Oops. Yeah, better. Okay. And now our grid area needs to be position relative. And it's working. Cool. And now we just have to wire up. Oh, that's a bit weird. Here I think we have some errors where we're not rendering all enough elements. And we're also hiding a bit early, I think. But this will be solvable, I guess. First, let's add the other grid areas. Those are lots and lots of fields. Not quite sure if using the spread, if building an object with these fields is advisable. But these are all signals, so this should not really be a problem. I could just define them as signals. Everything. So these ones I could just no, not these ones. These ones, it's just those 5 rows that I could merge into one row. But I'm not really sure if this really makes it much more readable. I think we will leave it as it is right now. Okay, let's start with the top left. The ref, it doesn't need a ref. The label is no top, no start frozen rows, start frozen columns. Width is width of left frozen columns. Height is height of top frozen rows. Content width is the same. I think we will just copy that. And the offset left is 0. And 0. So why are we not rendering anything? Ah yeah, because we have this bug with the, maybe we should fix that first. I think there's a rounding error in our calculation of visible thingies. And in here we should add rounding a bit. Start size and so this is still not working. It's only coming in really late here. So I have the fear that we are skipping too many or too few elements or something like that. Let's log our rows for now to see if this is really the first row, the second row. Oh no, that's not what I wanted to do. No, okay, that's correct. That's the first one. Maybe we should. Let's go into the visible. Oh no, I know where I'm wrong. Here, the visible column descriptors are incorrect. Because right here, I am not allowed to use the visible column row descriptors. Yeah, that's the problem. In here, I have to use the frozen column descriptors, left frozen column descriptors, and the top frozen row descriptors, like that. And now we have the 0 here. Perfect. Now this is working. Now we can check out this rendering issue right here, that the elements are running a bit too late. We can check that out in a moment. But wait, let me just remove the yellow color because that is annoying. Okay. We don't have anything to scroll here. Let's make that smaller. And now we have something to scroll. Yeah, here it's the same issue. That the data is coming way too slow. I think we need to, in our calculation of the visible columns and visible rows, there we need to account for the offset as well, I think. I think this is the problem. Let's check that out. When calculating the visible unfrozen column descriptors, calculate visible items. Now the start and end positions are all 0 based. And the start of the visible area. So we have all the I think this should be scroll left plus the offset of this area, which is the width of left frozen columns. Now the same thing here, plus height of top frozen rows. Yeah, and now it's working. Great. Cool. Another bug fixed. Okay, now let's get to the next area, the top center one. Maybe I think I will rename those and use coordinates because this is much simpler to reason about. I think we will be using top left and center namings everywhere, but for now let's just use top left area, top center area. Column and row dimensions, visible column descriptors is unfrozen column descriptors. Top frozen row descriptors, this is correct. Width of unfrozen container. Width of unfrozen columns. Offset left is width of left frozen columns. Perfect, this should fix the top center because the ref is missing. ref. Oop. Oh, what is the naming scheme? First, the columns. So these are the unfrozen columns. How did I call it? Area. And the unfrozen rows in top center. No, this is not right. Unfrozen columns and top area and start frozen rows. That is the right one. Perfect. Absolutely buttery smooth. I think later we could try sharing this link with in the chat so that I can get feedback how this is working on other devices. But so far, this is looking kind of good, I'd say. Okay, so, no, the offset top is correct. Yeah, no, that's correct. Now let's go ahead with the top right area. Unfrozen column, no, that's not right. These are the end frozen columns. And this doesn't need a ref because it's not synchronized with anything. And those are the right frozen column descriptors, top frozen rows. The width is width of right frozen columns, width of right frozen columns, and the offset is width of left frozen columns plus the width of the unfrozen columns container. Why is my content not there? Something must be off. Right frozen column descriptors, top frozen row descriptors, width of right frozen columns, height of top frozen rows, top right. Content width of right frozen columns. This is correct. Height of top frozen rows. So this one is not working. It's just rendering nothing, right? Is that already a cell? Wait. We have our top right area. In there we have the content. Yeah, this is just the placeholder for the size. This is the content. And in here is a button. And this button is not visible. Why is the button not visible? And the offset is not right. We have 300 pixels with position to the left, but we want 0 pixels to the left. Okay, where is the problem? The start of the dimension plus the offset. I think the offset might be incorrect. Minus 50? Yeah, the width could never be negative. This is not, no, that's correct. Error. So we get -50 in offset left. How is that possible? Width of left rows and columns. This is obviously working, so the width of the frozen column container, but this is also working. What? So we have here our top left area with width 80. And we have that one with width of 560. So these are the width of the unfrozen columns. So the first render has left frozen column width of 80, width of unfrozen columns. Okay, that's correct, because first we have a grid width of 0 pixels, but then it gets fixed and returns a new value. So offset left should, okay. So here we are not logging the most accurate current values. So now we have 640. So we have an offset of 640. So it's those 80 plus 560 is 640. That's correct. And now I can do for this column. So the offset seems to be correct, but I think it's not correct how I'm using the offset. The start of the column dimension minus the props offset. Wondering why these elements are perfectly fine. So I'd expect is a good idea. Yeah, of course. So how many? 1, 2, 0, 1, 2, 3, 4, 5. So when index is 5, then let's log that. Thanks. 1030 is the start of that column. Oh, the offset is not the... That's incorrect. The offset is not the... That's the problem. Top center, here it's correct, but here it's not the width of the unfrozen column container, but the width of all unfrozen columns, because those are in between. Width of unfrozen columns, like that. And now we have our button perfectly positioned. Cool. So I just misused the component. Now let's get ahead to the mid left area. Mid left. Left frozen column descriptors. Unfrozen row descriptors, but only the visible unfrozen row descriptors. Then the width of the right frozen, no, width of left frozen columns, height of unfrozen rows, container, width of left frozen column, and height of unfrozen rows, and the offset left is 0, and the offset top is height of top frozen rows. Now the ref is missing. And that one has to go. Cool. Only 1, 2, 3, 4 areas remaining. Center is working. Now let's do mid right. Let's fix the label here. This was centers. Mid. For I used, let's use mid area, top mid. Top left, top mid, top right, mid left, mid mid. Mid right. That one is already correct. The visible columns are the visible unfrozen columns. That's correct. The visible rows are... No, wait, this is not correct. Right, frozen column descriptors, like that. The width of the mid-right is width of right row and columns. Height is correct. Content width is width of right row and columns and height of unfrozen rows. That's correct. And now the offset is again width of less frozen columns plus width of unfrozen columns, like that. And now we should have our mid-right area. Perfect. Now let's see if I'm scrolling slowly. Yeah, then exactly those 7, 1, 2, 3, 4, 5, 6, 7, 8. Why are 8 cells being rebuilt? And why only 7 rebuilt? 1, 2, 3, 4, 5, 6, 7, 8. So up here I'm showing the next column, but in here I'm not showing the next column. Is the virtualization working up here? No, the virtualization is not working in the top center. Top center. Here, something is incorrect here. Unfrozen visible columns. Visible unfrozen columns, like that. And now, yeah, now we're getting those 8 calls for all 8 rows. Perfect. Okay, so we really have to be super duper careful. Maybe we are going to build some kind of a lookup map. So that we can just look there. Yeah, I think this might be good. Then I can loop over that. Yeah, I think this might be cool. So for each area, let's do it like that. For each area, we have a label. No, we have a top name, vertical name, maybe vertical name top, horizontal name left, for each area we need, those are more or less these ones. We have the visible column descriptors. These are only dependent on the vertical config, top, mid, start, mid, end. Start is so generic. But yeah, I think there's no reason to, with vertical config, to name it top, mid, and bottom. Const horizontal config is left, mid, right. And now we can place the visible column descriptors in the horizontal config, because for the left column, visible column descriptors are the left frozen column descriptors. And we will just put in the signal itself and not the direct values. Then we need the width, which will be the width of left frozen columns. We need the content width, which will be the width of left frozen columns, and offset left, which will be 0. Same thing here. In the middle column, we have the visible unfrozen column descriptors, width of unfrozen column container, width of unfrozen columns, and the offset is width of left frozen columns. And now the right ones. Yeah, I think this is much better. And I only have to define this once, and then I can multiply these values out, basically. Then I also need some kind of a lookup ref. Let's check if this is working. Let's do it like that. Button. Can I do that? Ref.button. No, that's incorrect. Can I do it like that? So now my ref has a field button, and the ref itself is just, it's just working perfectly. It's just looking inside of that, so I can build lookup maps for the refs as well. Yeah, I can just build a lookup map for the refs and use those as well. So I can really just iterate over the different areas. But now to get back to this, I'm not quite sure where I left off here. Visible column descriptors. On the right are the right frozen column descriptors. The width are the width of right frozen columns. Content width is the width of right frozen columns. And the offset is width of left frozen columns. This will be a signal. Width of unfrozen columns, like that. Just make sure. But I don't think we need the brackets. Okay, so we have the horizontal config. Now we need the vertical config. Which will be the visible row descriptor, the height, the content height, and the offset at the top. So for the top part, we have the top frozen row descriptors. We have the height of the top frozen rows, the content height is correct as well, and the offset top is 0. That's okay as well. This has to be an accessor function. These as well. Now let's define that for the mid stuff. Visible row descriptors are the visible unfrozen rows. Height is the height of unfrozen row container. Height of unfrozen rows. the offset top is height of top frozen rows. Okay. Now for the bottom part, visible, no, bottom frozen row descriptors, height of bottom frozen rows, height of bottom frozen rows, and the offset is, wait, this is not correct, like that, height of top frozen rows, and in here we have to do the calculation, height of unfrozen rows. So now we have our config. Now we need to loop over this stuff. Now we need the lookup map for the refs now. Yeah. And there we will do top. We're going to do it like that, or nested. Nested object or compound keys. I think we're going to do a nested object. Left, undefined, call it mid. Yeah, mid, left, right, mid, and top, mid, bottom. Top, mid, bottom. Of course, here we need right. So top mid is a ref. You know what? Let's add a type for those area keys just so that we have them defined somewhere. And we have vertical keys, where we have top, mid, bottom. Now let's add a type for those. Type horizontal key is type of horizontal keys number. Perfect. Now we have the vertical key, and then we can build the refs, which is an object where we have key in horizontal key, and key in vertical key, HTML div element. Perfect. Left, mid, right. You know what? Let's just add all of those. I think we can just do it like that. Now we have our area refs. Now we can just do this where we want area refs. This is the left one, so we are in the middle. On the left, dot scroll top equal to top. Yeah, this is much better. So we have the mid, no, so this was mid left, so now we have horizontal key, vertical key. First the horizontal key. Oh. Yeah, better. So we have the left mid one, then we need the mid top one, where we are going to synchronous scroll left with left. Area refs dot mid dot scroll top is top. Area refs dot mid scroll left is equal to left, and area refs dot mid dot bottom dot scroll left equal to left, and area refs dot right dot mid dot scroll top. Like that. Now we have our vertical config. Which will just be, let's define that for now, just to be sure, where we have key in vertical key, and we have an object of visible row. And we have the height, which is an accessor of number. We have the content height, which is accessor number. And we have the offset top, which is also an accessor of type number. You need an array. Yeah, perfect. Now same thing with the horizontal ones. I think I have somewhere must be a syntax error, I guess, which is why we cannot format this stuff right now. Oops. The column width, content width, offset left. And now we can just loop over the horizontal keys, flat map X key, let's call it that. Now loop over the vertical keys. No, we have to loop over the vertical ones first. Vertical keys, Y key. Then we are going to loop over the horizontal keys .x dot map X key. and we are returning we can just return the grid area. Where we have the label, which will be calculated with the X key, Y key, and area. Then we can just use these, pass down this cell. This should be fine in here. Then we have the column dimensions, which should be fine with the row dimensions. This is fine. Visible column descriptors is from the Y vertical config, no, horizontal config. With the X key dot visible column descriptors. Now I can call that. Here we have the vertical config, Y key dot visible row descriptors. Maybe let's do it like that. Content width, offset left, and the width, Now we have all horizontals. Now let's add the verticals. Let's add the height. Offset top. And with the road is no, I already got those like that. Like, can I do that? Yeah, I can. I've already declared areas. No, those are not called areas. Where have I used areas already? Here, okay. We can remove that. Now we can format that. And now we can just render areas, I guess. Yeah, the refs are missing, okay. Area refs, X key, Y key. I'm actually a bit amazed that this is working already. Now the question is if I want to move the grid area out, or if I just inline that in here, because the grid area itself, the call of the grid area component is almost 20 lines, and the whole grid area component, okay, it's a bit longer. 85 to 35. So we have about 50 lines. So we have 20 lines more inline in here. Is that a problem? Because right now we would save those lines. 15 here. You know what, let's do this. Let's try it out for a second, maybe. Oops. Let's use the area ref here. Let's use that here. Width. I think I'm reusing some of those values, right? No, not really. Width and height. Where's the height? There's the height. Yeah, no, I don't like that. Let's leave it as it was before. Yeah, I like that better. Now I have the areas in here. We could theoretically think if you want to move that down in here, but I think we are not going to do that. So is this working now? So the scrolling works perfectly fine. Let's try it with a larger grid. So scrolling is still perfectly in sync. Let's add more columns. Like that. Yeah, now we have the columns. Everything's still working perfectly fine. Maybe let's increase the size of the frozen stuff thingy. Let's say we have 5 at the top, 2 on the left, 5 on the bottom, and 2 on the right. It's just working perfectly fine. Cool. So I'm going to commit that, but then we will be cleaning that up a bit. Let's just commit that, and then we will go for a short break. Implement grid areas for frozen rows and columns. Perfect. Okay. Then I'd say we're going for a 5-minute break until 16.5. And then we will go ahead with refactoring this a bit more before we are going to go further with the next features of our application. So I will see you all soon. Okay, that break was a bit longer than previously anticipated. So just a quick recap. We have now built our virtualized grid component, and we added this one prop, frozen areas, where we can supply values for the amount of frozen rows. So 5 at the top. Let's check if it's actually 5. Yeah, we got 0, 1, 2, 3, 4, which are frozen. Then are all the unfrozen rows, and then in the end we have. Oh no, this is not correct. Ew. So we have too many frozen rows at the bottom, and on the right we also have too many. So on the left we have 2. This is working. On the right we have 3. So 1 too many, and on the bottom we have too many as well. So there's still some bug in our calculation, but I think this should be quite easy because it's, I guess. No. So the height calculation is incorrect already. First frozen column index. So we have all columns. And let's just do that with rows, like here. So from N to M. Okay. Yeah, so we have in the end 9 that are not part of the what? Oh, because in the end we only have to remove that one. That's the error. Okay, and now we need a +1 or something like that. So the last unfrozen is -1, like that. And now we have 5. 1, 2, 3, 4, 5 at the bottom, 5 at the top. And same thing with the frozen columns. But minus right, minus bottom. Yeah, now it's better. Beautiful. I really like that. And no problems with any overscroll, overflows, or something like that. I'm quite surprised, actually. It's really fun on a touchscreen because on a touchpad because you can scroll diagonally and see all areas moving at the same time. But of course, we're still completely unstyled. So let's commit that as a bug fix. Fix bug where frozen row counts would be calculated incorrectly. Okay, so now let's rework this a bit and refactor this a bit. Because right now it's still a bit much within that component file, I think. So we have 417 lines for the calculation, and I think the frozen stuff is something that we can rework and that we can make much better. So we just have a frozen dimension and can put anything in here that we are using on the outside within that frozen dimension, I think. And the calculation of the frozen dimension is basically the same from bottom to top, with just some parameters changed. Do frozen stuff. Let's do it like that for now. So in here we want all of that. No, these are area calculations for one dimension. Calculate dimensions for calculate direction dimension. Okay, so we have a first unfrozen index. So we will just remove the column right here. And we'll pass in the config right here, just so that we can add type annotations and don't have to care about the order, because this will be quite a lot of arguments, I think. So we have the frozen count at start, frozen count at end, so these have to be accessors. Because of course the props may change. So unfrozen is config dot frozen count at start. And we have a last unfrozen index. And we have a frozen count at the end, -1. And we have a width of left frozen columns. No, that's not correct. That is the size of first frozen area. Here we are going to do if not config return 0. If we have 0 items, then we are at 0. Then we need the dimensions. Which will be an accessor of element dimension range array. So we have here config.item dimensions.start item dimensions frozen areas left. We know I have that only once more. Config.frozen count at start. Yeah, so this is a bit annoying because here we are already checking if the value is valid and not undefined. But since we are calling a function that has this union return type, we have to add this non-null assertion right here. So we have a size of the first frozen area. We have the size of the second frozen area, size of second frozen area. Config.frozen at end. And again, we can do that as the multi-editing config.item count. Now we need more from and to, where we have the column dimension with our config.item dimensions. The last frozen index, config item count, blah blah blah. Width of unfrozen column container. So this is the size of unfrozen area. Grid dimensions. So we will just use that here. Grid. No. What do we need? We need the total width, which is an accessor of number. And then I think we will just move that function out of this component, and I think even into another file. So instead of grid dimensions.width, we are using config.totalWidth. Maybe available width is better. Available width. Width of last frozen column is the size of the first frozen area. Oops. Size of first frozen area plus size of second frozen area. Size of unfrozen items. First unfrozen index. Last unfrozen index. And this is working. Left frozen column descriptors. Ew. Ew, we have a generic in here. So we need a generic right here. Oh, we don't have the descriptors now. The column descriptors. The descriptor extends column descriptor or row descriptor. Here. Like that. So we have left frozen column descriptors. So these are the first frozen descriptors. Config dot item descriptors, the descriptor array, but I guess this is an accessor. Yeah, exactly. Item descriptors, first unfrozen index, unfrozen descriptors, unfrozen index, and last unfrozen index. And we have the second frozen descriptor, second frozen descriptors, which are conv.item descriptors, last unfrozen index. Okay, and now we can return all that. We need the size of first frozen area. Wait, let's check. Let's comment that out. And let's see. We need the descriptors of all areas. And we need the sizes. Size, 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 and size. And we are calculating the area descriptors. So we have sizes for each area, and we have the descriptors for each area, but we also have the size for the unfrozen. For the unfrozen area, we have the size of the area itself. So let's just do that. Descriptors, and we have a size of first frozen area. Here the second frozen, which is the same thing as that, just with a second. Second. And we have the unfrozen, where we have the size is size of unfrozen area size, and the item size. And we have the descriptors. With the unfrozen descriptors here, like that. Okay, so now we can calculate area descriptors. So now we want to call that for the horizontal and the vertical stuff. So calculate area descriptors, and now available width is, oops, that's not correct. That has to be available size. I think we are going to put that one inside of that as well. Grid dimensions dot width, like that. We have the item count is we have the item descriptors, column descriptors. We have item dimensions, column dimensions, and we have a frozen count at start is props dot frozen areas dot. We are at 4 horizontal, so we are getting in columns, so we have left and right. So, of course, here we need number undefined as well. And this might even be something where we could write some tests, some test cases for this function, because right now we have all calculations inside of that calculate area descriptors function. Like that. And props are frozen areas dot left. So now let's move that one inside of that as well. We could even build the config directly in that function. But okay, let's not get ahead of ourselves. Let's first. No, you know what? I think we are going to leave that for now in here, and then we are putting that into different functions. Yeah, I think I like that. But that means we have to add the scroll container. So these are all accessors, right? Yes. This would be a create memo. This would be a create memo. And this would be a create memo. This is just a number. This is fine to calculate, maybe a bit too often. And there we have everything memoed. Okay. So now we are able to calculate area descriptors. Now we have our horizontal area. Let's move that out of this function maybe. All the way at the bottom. Now we can remove that stuff. Are we still using that somewhere? Where are we using that? In here. For the total size of our content. Yeah, I think that's okay. But now first we need to add the vertical area. So this is the height. Item count is determined by the amount of rows. Here we have the row descriptors. Here we have the row dimensions. Bottom and top. Let's switch that around, top, bottom. And now we can use that. Now we can use that to calculate our visible stuff. Where we can just say, what are we going to do with the rows? We use the vertical area descriptors. Oh no. Unfrozen descriptors. Vertical area descriptors. Unfrozen area size. And we use height of top frozen rows. These are the vertical area descriptors. First frozen dot size. The same thing here, but only unfrozen column descriptors. And we need to do that with columns, columns. And instead of using the vertical ones, we are using the horizontal area descriptors. Horizontal. Like that. And now we need to use that again. Top frozen row descriptors is vertical area descriptors, first unfrozen descriptors. That one is vertical area descriptors. First frozen dot size. No, as an accessor, we need the content height. This is okay. Yeah, perfect. Then we need the height of the unfrozen row container. This is vertical area descriptors, unfrozen area size. Vertical area vertical area descriptors, unfrozen item size, and vertical second descriptors, vertical area second size, vertical second size. And this is already working. Now we need to fix the horizontal config. Not quite sure if this is making it really that much better. But I think we can move even more calculations out of this. Now we need to fix the horizontal config. So for the next, for the left part, we have horizontal area descriptors. First descriptors. Horizontal first size. Horizontal unfrozen area size. Horizontal unfrozen item size. Horizontal second descriptors. Horizontal second size. And horizontal unfrozen item size. So now it should already be working again. Yeah, that's looking. Ooh. I killed it. Okay, so the rows are working really enough. Oh, because somewhere I used scroll left instead of scroll top, I think. Visible unfrozen columns. Yeah, in here we use scroll top, but we need to scroll left. Yeah, okay, perfect. Lucky. Whew. This would have been quite annoying otherwise. So let's scroll all the way to the top and scroll a bit to see. Yeah, we are rendering 10 cells on every scroll. 1, 2, 3, 4, 5, 6, 7, 8, 9, and somewhere in there is one extra, I guess. Yeah, that one here. Maybe if we decrease the size a bit, we're still at 10. Still at 10. Let's look at one row here. So 1, 2 on the left. 1, nothing on the right. 1, 2, 3, 4, 5, 6. 6 in the middle. We are at 8. And now we have 2 frozen in the end, I think. Inspect. Yeah, we have 2 frozen in the end. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, yeah, it's all 10 visible columns anyhow. So nothing with overflow or no hidden elements rendered right now. Okay, so now let's go ahead and try to pull out even more. So we have these descriptors right here. This is okay, I guess. That we have up here. Then we calculate the area descriptor. This is fine for me. So this vertical config stuff, this is a bit annoying for me still. So this is really only using the area descriptors. This is good because this is also generic. Those 2 configs are also generic, just with different keys: top, mid, bottom, and left, mid, right. So we can just pull that into another function. So let's first type area descriptor how is it called here? Descriptor. Wait, let's first unify these descriptor interfaces. So this is an indexed element in the end. So maybe let's just change that to be an indexed item, and so that is the item. This is better. Let's remove that. And now we can indexed item d column. Indexed item d column. And in here we have t item and have here indexed item t item. Now we can change that to be indexed items. Now we can change these names as well. So let's go through this once more. These are indexed columns, indexed rows, column dimensions is okay, row dimensions is okay. So what is your problem? Oops. Oh, we messed up the type. Where is our indexed item? Here, item. So here we can just use a new function inside of our array helpers, export function index items, t item, t read only array t item, return items dot map, item index, item index, like that. Oh no, it's using map array. So when the columns change, we are not recreating these indexed columns. This is quite important. So let's move that back into the component because it's a solid specific thing. And here we are going to use map array. Like that. And we are directly calling it, so we can do that here as well. Where are we? Right here we can just say index items props.columns. Same thing here. Index items props.rows. Oh no. Oh, we still have type errors. Yeah, I think this error will fix itself. So column dimensions. This is okay for now. If we just keep calculating the sizes. This is only used in one place, right? So let's just use that. Column dimensions. Dot end. Yeah, and this will just, let's do it like that. Yeah, I think I need, so now I can skip that one, I can skip that one. Now we have even more area descriptors, where we use the grid dimensions, item code index, dimension, blah blah blah. So now I think this one is a static type, Perfect. So now I can... Oh, let's first look for other descriptor stuff. No, you know what? Let's do it like that. So we have one T item here. So we have a type for that, type area descriptors. This is a name that I think will change soon. And this is of return type. Ooh, I think I'm not on the... On what TypeScript version am I? I think this is I need a feature that's only in the newer TypeScript version, in 4.7, which is not out yet. Yeah, so I wanted to use this function and infer the return type independently from the item. So we want to apply the generic when extracting the type. Yeah, so we need to write that type for ourselves. Don't really like that. But this is again something that will move to another file, so it's not too bad. Descriptors are an accessor of an indexed item of the item. Size repeat accessor of number. So this descriptor's name will change soon as well. So now we can simply return this. Now we can rename that to indexed items. Oh, sorry. To index items. Now we can rename that one. Oh no, we can leave it as that, I think. Now we need to change the descriptor names as well. First frozen, let's just call it items. Wait. Do we need the item count? Item group props, those are all, and those are all index columns. Yeah, so let's remove the item count, I'd say. Item count. Like that. Good. So now we get per area, we get back the indexed items of that area and the size of that area. What is missing from the config? We already have that. We have the sizes of the area. We have the content size of the area. No, that's still missing. No, we already have that. And we have the offset that is remaining. So we can add that to the return type of this one. So we have, let's say, offset, position offset. And a position offset. Let's add that one as as well. Position. Yeah, no, let's don't do that. Position offset is size of first frozen area. And the position offset here. Oh no, that's not correct. Here we have the size of the first frozen area. And here we have size of first frozen area plus size of unfrozen items. Like that. Now we can get into our configs and remove this one because this is just okay. Let's add the offset to the first one as well. That, and now we can change our configs a bit more by doing vertical descriptors, first frozen position offset, unfrozen position offset, and vertical area description, second frozen position offset. Yeah, now we have we really only have these descriptors for the config stuff. So we can basically remove that and only need a mapping from key to the correct the names. But this is only really usable for the labels. Let's make it working for now, and then we can continue refactoring. Item. Okay, working again, great. Now we have these config stuff, and we don't really need the config anymore, I'd say. Wait, the keys are still quite useful. So let's now just use... No, I don't think I want to use the keys. So for this unfrozen part, I have these. Maybe we should enhance that with area size and item size, because then we really are unified. Like that. This is the area. Oops. Area size, and we have the item size, which is basically the same. Here we have the area size and the item size as well. And now all that is remaining for this one is the mapping from left to, from the key to the area descriptor. So we have our type area descriptor, the item. So everything, the last thing that is missing in here is the visible indexed items, and then we truly are unified. Do I need that? Yeah, I need that. No, I don't need that. Okay. First frozen. Area size. Area size. And now I really only have left is a mapping from a key to an area descriptor of type t-row. Unfrozen vertical descriptors. Second frozen. Same thing here, only for t columns. We have horizontal area descriptors. First, horizontal area descriptors, unfrozen, unfrozen, and second. And now we can indexed items, area size, position offset, area size. No, those are just the indexed items. Now we removed the visible stuff. Okay, we can do that soon. Content height is area size. No, item size. Here, area size. And this is the position offset. Okay. Now we can just say that we pass in the area description into this grid area. Yeah, like that. So we need a horizontal is an area descriptor, T column. Vertical is an area descriptor, T row. Now we don't need those anymore. And now we can just say horizontal area size, vertical area size. For each vertical indexed items, yeah, we need to call that as well. Call that as well. In here we need props.horizontal indexed items. These are the columns. Perfect. Props dot the left offset is the horizontal descriptor in the position offset. In the vertical in the position offset. like that, and we need horizontal item size, vertical. I want to rename that to be total item size. Yeah. First frozen area descriptor item, unfrozen area descriptor item, and second frozen area descriptor item, like that. And now we can change that. Total item size, like that. Okay, so what is missing right now? Props and cell. Right here we need to pass in the horizontal is horizontal area descriptors, vertical area descriptors. We need to call that, I think. No. Okay, now we need to, oh no, we can just horizontal config, X key, and vertical config, Y key. Okay, now we are rendering all cells because we are not calculating the visible stuff, and now we are going to move that in here. Visible indexed items is an accessor of indexed item, like that. Then we have visible indexed items, and here we have this. Okay, we are going to move that in here. Const visible indexed items, create memo, and do that. Now we need the dimensions in here. Do we have that? Item dimension. We already have item dimensions. Item dimensions. Item dimensions. I think I need to call that. Here we have the unfrozen indexed items. These are called unfrozen descriptors so far. We can change that in a moment. The size of the visible area is size of unfrozen area. And here we have the first frozen, size of first frozen area, and now we need the scroll value, the scroll signal. Like that. Config.scroll value. like that. Perfect, perfect. Yeah, now we have all the calculation stuff in here, in this function. This should, in theory, make lots and lots of this stuff obsolete. So here we need the scroll value, scroll left, and scroll top. Like that. Okay. I think I'm killing my app right now because I'm rendering so many cells. Yeah, 10,000 cells and, I don't know, 20 columns. And there the browser is definitely not happy about that. So now, in the grid area, where we are looping over the indexed items, we are looping over the visible indexed items, and I think this is it. Okay, I'm quite happy about that. Yeah, this is working again. And now the question that is remaining is, do we need this config object up here? Oh, we still had some descriptor stuff down in there in this function. Like frozen indexed items. You know what, I think in here it's not really, I'm not using the index in here, right? So I can just use do that, and everything should work basically the same. No, because I have to change that to be just of type item. Like that. Yeah, and here we need the indexed item T row, like that. Indexed item T column. And in here we need like that. Indexed item T column and indexed item T row. Okay, that means we can greatly improve the names in our calculations. Fuck. Okay, these need to be indexed items. Damn. Okay, like that. But I still think calculate visible items, area descriptor. Yeah, I think we should let that as indexed items. Indexed items and visible indexed items. Now let's check if we have any descriptors remaining. Area. So we have these ones. Index row, indexed column. And these are just area stuff. Okay, so now what's happening in our virtualized grid component? We're setting up some refs for our areas. This is still needed, definitely. Then we are setting the scroll values to our refs. This is needed. This is just a pure function. We can move that all the way to the bottom for now. So we calculate column dimensions and row dimensions. It's always high start end. Yeah, maybe let's, if we only map to that. Oh no, then we need another additional mapping step. Yeah, no, let's leave it at that. Yeah, I think we'll leave it at that. Then we're calculating the horizontal areas. I think we will just do calculate area. Calculate direction, calculate dimension. Calculate direction, I think. Direction areas, maybe horizontal areas, and we have vertical areas. Here we have the available size. We have our items with the sizes of the items and how many frozen elements there are and the scroll position. And this is all that we need to calculate which elements are visible at what position. Wait, is that used anywhere else? Yeah, we need that for the okay. Okay, we need that out here. Okay, this is okay. This is fine. Oh, then we have the config, and we map over the config keys to generate the areas. No, I think I like that. So now let's move stuff out of this file. Grid area.tsx. Of course, we need some. We have our. Let's call it CSS scope. Wait, where is it? Where is it? Yeah, it's lots of stuff in that file. It's good that we are moving that out. Like that. Then we can do this. We can do this. Then we need those. What have we called that? selection areas. Calculate item positions, maybe. This is better, I think. And these are these item positions? No, these are areas. Areas, and this is a virtualized area. This is the data for the virtualized area, and this is calculated virtualized area. That's okay. So we have that up to here. Element dimension range. So we're using that one to calculate the dimensions here, and we're using that one for calculate sizes. So let's do it like that. Whoops. Like that. Export. Where's our area dimension type? Here. Like that. Get virtualized areas. Now we can import. Import. I want to import. Now I can import that. Now the indexed item. No, here. Map array solid, and this returns indexed items, so we can define the type in there as well. Like this. Now, where were we? This one is done. This one is done. No, I wasn't here already. Here. Import the indexed item. Import memo. Calculate visible items. So we need the element dimension range. Then we can calculate this. Now we can add the import here. Now we have our calculate virtualized areas. It's all coming together. Now we are indexing the items, we are accumulating the size, We are calculating the virtualized areas. Oops. Virtualized area data. Here. Like that. Now we need to import the grid area. And now we need to add, area descriptor. Is that still called area descriptor? No, it's virtualized area data. Some element dimension ref, some component from solid, virtualized grid cell props, and D4 from solid. Perfect, now we have the grid area. You can pass in the ref. Alternative, I'm not sure. Alternatively, we could pass in the scroll value and handle the ref in here. Then we don't need the ref lookup map. But we need the refs to, no, we just have to pass down the scroll position. But here we can make sure that, no, since we batch it, it should be irrelevant. So I think we are going to remove the refs. Let's do it like that. Let's add a we only needed that very few scroll elements. Yeah, no, I think we are going to so where could we add it? So we would have to add it to the virtualized area data, and here we could add the scroll position. I think we may do that. Scroll position, accessor number. And now the grid area can let scroll container HTML div element ref is scroll container No, I don't think we are going to do that. Because we don't know if we want to set scroll left or scroll top. Yeah, we could pass down both, but then all virtualized grid areas would need both the left and the top scroll positions. Yeah, they need that anyway. Scroll left, scroll top. No, yeah, let's do it like that. Scroll container HTML div element scroll container. Let's remove the ref. Create a render effect. I think Solid offers another method. Solid docs. Oh no. Because the effect will, I think, will be scheduled a bit later. Create reaction. What's that? That is run the first time the expression is notified of a change. Only the first time. Okay, so this is not what we want. Ooh, this is interesting. waits for the rendering path to complete. Wait, render fade immediately calls the function. Oh, refs will not be set before the initial effect call. Okay, so we need to create effect. Oops. Whoops. Props will. What? So we have 2 scroll positions right now? No, because each direction only has to supply one area, one scroll value. So this one has to be a scroll position, access or number, and then in here we can say props dot vertical dot scroll position. Scroll container scroll left is props dot vertical scroll position, but the horizontal one, of course. Not quite sure if this is what we want, but let's try that. The first scroll position 0. Scroll position 0, and in the unfrozen part there we are using config.scroll value. Yeah. Like that. And now we don't need the area refs anymore. Now we don't need this effect anymore. And we can skip that. Let's see if this is still working. Yeah, perfect. This is a bit odd. 21 cells recreated. Yeah, because we are seeing roughly 21 rows. That's okay. Okay, and again 21. Okay. Good. Good. So now we skip the refs. The scroll bar dummy is still required because we need that to feed the scroll position. Then we're indexing the columns. We are calculating the column dimensions. So I think let's just move that out and create this one. No, I don't want to create an extra array because we could move that because this is the only thing that differs. Also, yeah, we can move that out. Element dimensions. Item ranges. The items is a read-only array of the item. Get size is a function of item, the item number. And in here we are doing that. Very interesting question. I guess there are some seams in the chassis of the phone so that dust can get in there. So we are mapping over the items. We are calling items dot get size item, and then we are accumulating the size. And now that one doesn't have to be public. And now we are just calling create item ranges. Is that, yeah, that is working. Like that, column dimensions. Let's call it column ranges. I like that better. But the return value is missing. Yeah, no, sorry, this is an English stream today. So now we have our column ranges, element dimension range here, and now we can do the same here, create item ranges with props.getRowHeight. And we should still be working. Yeah, perfect. Now we have our horizontal. So we have the dimension, the row ranges. We have our areas and the configs and create those elements then. So now, is that something that we still need? So we could also just iterate over the keys of those areas, but then we don't have the labels. Let's take a look how if the labels are still worth our time. Left mid area. Yeah, so I think the names here are not really so important because, as you can see in the DevTools, it's quite easily to identify where the area is. So the name itself is probably the last thing where I will look, because I will just look at the UI. So let's just remove those. And then we can use the keys from our vertical areas. So we need let's add a new folder. Helpers. Move our array helpers in here. DS utils export function type save keys. Team. Return object.keys. As key of t. Alright. Now we have a function that we can call to, because object.keys always returns an array of strings, but we want the array to be correctly typed. And now we can just do this. Type save keys vertical config. Don't let map y key, that's okay. Then we can use type save keys. No, we don't even need the keys, right? We just need the values. Let's iterate over the vertical areas. Vertical. Then we iterate over object.values horizontal areas. Now we remove the label. Let's add that. And now we can just do horizontal, vertical, like that. And we should still be working. So something changed. So my frozen stuff is no longer working anymore. Because of the order. The order is incorrect. Calculate virtualized areas. We have to return the unfrozen first. Yeah, perfect. And now it's working again. So now we don't need these config objects anymore. We can remove the label. And do it like this. Let's call that vertical and horizontal. That doesn't cost us much. So now we are down to this can be removed, this can be removed, this and this. 145 lines. I kind of like that. Calculate virtualized areas is using the calculate visible items within. This is just 120 lines. Calculate visible items. This is very short just for the calculation of the items itself. Yeah, no, I like that. And it's still performant. Yeah, even with so many items, it's still performant enough, I think. I can already see that it's no longer scrolling at a very high frame rate. But this is, I don't know, when you have such a large grid, I think so many items are very seldomly only displayed at the same time, so many columns and so many rows. I like that. In the end, we can still optimize some stuff, I guess. But now I'm thinking if we should move the calculation of the visible elements inside of the grid area so that we could then selectively decide if the grid areas update in real time or not. Let's add that as a to-do, because this is something that we can do purely within the virtualized grid. It's something maybe for the next couple of days when we are a bit bored or have some time slots to fill. To do move calculation of visible items inside of grid area. However, the inside of the grid area does not make sense because this area here on the left and this in the middle need the same visible items, so we only want to calculate it once. But maybe no. But maybe the rendering itself could be delayed. Okay, we will take a look at that. Maybe later, some other time. Okay, so now we successfully refactor virtualized grid. And now I'm really happy with the current state of this component. Maybe let's remove some of our columns again, because they were just added for demonstration purposes. Yeah, so now we have our columns and our rows, and it's all virtualized, and it can be fixed on the left, fixed on the right. We can still recalculate everything without rebuilding anything. Yeah, that's cool. I I really like that. And now we can, let's take a look at our, where is it? At the timetable. So we want the virtualization. We finished that today. We took a bit longer than expected. We only have roughly an hour left for today. But the base setup and maybe column resize is something that I'd still like to do. So now we are basically starting for the first time with the data grid component. So we have this virtualized grid. And now let's add a new library for the data grid. Now for the data grid. Let's first try to think about an interface. So what I'd like to do is I like to have a function which I can use to create those columns. So maybe users want to be able to say, I want it to be type safe. So of course I could add the columns directly here inline, but that would blow up the component file. So I want to make it very easy to move the column definitions out. So users could just say columns equals blah blah blah. But now we don't have any type safety because you can add any properties here that you want. And I want to help the user to not make any mistakes. So I want to provide a function build columns where you can add columns with over specific d-item. And in here we pass in column definitions, which would be some kind of object, a list of objects, of course, that we can then add to the user interface. So maybe let's think about what a column template needs. Let's say column template first. Each column definitely needs some kind of a human readable name. So it's something that we can render up here, but we also need to display it in some kind of selection. For example, where I want to select which columns are currently visible. When we want to remove the visible columns and reorder the columns. Oh, this is something that I forgot here in the list, that we want to reorder the columns. So our column template definitely has a title. And we definitely need a function to get a simple string out of the cell, because oftentimes for copy paste, for example, you need plain text. When exporting to Excel, maybe you need the plain text. So every cell needs a plain text representation, every cell. Text. Okay, and now let's say from item, because at a later point in time we will have multiple kinds of rows. Maybe you want to build group rows and stuff like that, and there you need to be able to extract the text as well. So we have a column template, it's generic with a specific item type. And maybe to make it easier to call other functions, we just pass in the self, maybe as an extra argument. Options. Self is a column template of the same item. So that you can use arrow functions while still calling other values, other functions on the column template itself. So you're not getting problems with any of these bindings. So in get plain text should return a string or a number, or let's say a boolean is plain text as well, or null or undefined. This is fine as well. And maybe we will add later a date object or, for example, but these are enough for now. So we have a title that we can use for the grid head. Maybe we will make it even more flexible so that you can directly take control over rendering of the grid head. And we will have a get plain text from item function where you can decide how each item is displayed in the columns for now. But again, this has to return simple primitives. Maybe we will later we will enhance this so that you are able to render. You know what? Let's call it render item. Let's call it item because it's a component that renders the item. And this gets props. And returns anything that's rendered. JSX.element. I kind of like that. So now when building a column template, these are basically the only real requirements for a column. So let's say when building columns, you have to pass in definitions, which will be column templates of type the item that you can pass in, and we will just return the definitions. So this function is for the sole purpose of helping you with type safety. So then you can either build your column templates directly in here, or you can build the columns outside of the component in a different file. So let's use that for now. Create build columns, build columns, and we will pass in the generic as well, and maybe we will even create helpers. Create grid. And this returns a bunch of things, like, for example, the grid component. And build columns. And here we will just add this. Like that. So now you can just say we have a const person grid is create grid person. Of course, you can also do that directly within the file because as we are in Solid, we don't run this function more often than we have to. So we have our person grid. And now we can build columns, person grid dot build columns. Now we can skip the generic. I think I have to remove that here, like that. And now I can have a title. Let's call it ID, and we have an item component. And here we can render stuff. For example, we can simply return. Oh, I think we always have to return a JSX element. props.item.id. Let's remove that and that. So the column width will be editable later. Let's see if we can get to that today. So we have our ID column. We have our name column. Then we have the country column. We have the date of birth, where we can do local date string. And what else? We have the country, and we have, say, an action on the right. Maybe we will allow to pass in an empty string here, or yeah, I don't know yet. Let's pass in an empty string for now, and there we will render just a button for now. Is there a save emoji? Disk? Disk? No, these are not save emojis. Floppy? Floppy. Okay, so now we are able to define our columns, and now we want to render our grid. And I think for that we can just return another component, the grid component itself. That has some props. I think we won't be, let's not use arrow functions in here, just so that we can make sure that each function has a name. And here we return our virtualized grid. Width, number, height, number. I think we will later move that grid component out. Items, the item array, columns is column template, the ID item array, so width, height, items, and columns. Props. So the frozen areas, I think this will be something that's living on the columns for now. So let's just freeze the top one row for the header. And otherwise we don't freeze anything for now. Now we need some rows. This will come in a moment. Let's just for now say rows and items, because we need to transform these rows into different types of rows, because we have header rows and we have item rows. Rows and columns, get column width will just return 200 for now. Row height will just return 30 for now. And for the cell props, and now here we can use dynamic, I think. Component is cell props dot column dot item. And the item we will provide as cell props dot row. So what is missing? Property template is missing. Oh, okay, because column template. And this is cellprops.column. We still have a syntax error somewhere. In here. And now we're just saying sorry, I don't really like that one. But it is not generic. Let's try if this is working. Person grid. We need columns. These are our columns. We need items. These are our persons. Need to call that, I think. No? Store.persons. Yeah, that was it. And we need the height and the width. So width is dimensions dot width, and we need height, which is dimensions dot height. Okay. Now we have not too many frozen columns. Get row height 30, get column width 200. So this is working. We have that area empty. That area, yeah, this is top center. That's right, top right. Ooh. No, it doesn't really matter. Why is that down here? So we have a problem with line breaks. So we are not breaking correctly after each segment. That one. And then we have this in the bottom line. Why is that so low positioned? Why is that not directly below this one? Maybe we should do this not with inline block elements, but with a flexbox. Let's do it like that, and in here we are going to say display flex. You know what? Let's do CSS grid. Display grid. Grid column. So 3 columns and 3 rows. Yeah, cool. Okay. Now we are already able to display our data, but now we want, of course, okay, I think I need a new component now. Solid data grid. Export type. Let's call it data grid. Data grid props, the item. template. Let's move that out of the way. Yeah, like that. Then we have the column template. And we have a grid builder. Where we say create grid, the item, where we pass in column templates, where we pass in a grid component. Data grid. I think this is not working. Yeah, same problem as earlier. Or not? Yeah, yeah, same problem as earlier. So we need to do it like that. And now we can simply return data grid. Data grid. Data grid, and we spread in all the props. So let's do it like that. Template. Like that. Now we have our data grid. Now we have our grid builder. Now we can say create grid from person. And then we can render our grid component. Okay. And now we can edit our grid component to render the virtualized grid. Okay, so now let's build some rows. It's definitely a create memo. There we will be using map array. Let's define a row. So we have different row types, which can be a header row. So we have different levels of rows. So on the virtualized grid level, we have the header row and the data rows. And these data rows can further be divided in group rows and leaf nodes, item rows, and stuff like that. But I want to keep the functions monomorphic. That means so the JavaScript engines can optimize a function better when it's always called with objects of the same shape. When I now add a union type, I have different kinds of shapes for this function. which might slow down stuff unnecessarily, maybe. So maybe if I make sure that all elements of the union have the same keys, then this might not really be a problem. But then I have to manually make sure that all rows have the same shape. And this is not really something I'm too keen on, because we on a group row we have an items array where we have multiple items. On a leaf row we have just a single item. On a header row we don't have any items. Okay, but the main functions that will be called often are all those grouping and sorting functions, and these will only be called with a row, a data row, and not. Okay, so we can do it like that. We have type header row. This is definitely generic, where we have a template. Column template item. I think this is it for now. Then we have a type item row. There's a template. No, it doesn't have a template. It has an item, the item. And I think this is it for now already. So let's build a function that is creating some rows. Header row is create memo. Export type row type is row any type. Export type header row is extract row header. So now we have a header row. Now we can do the same for a item row, just so that we have easy access to those types if and when we need them. So here we are going to return a header row. No, wait, that's not correct. The row itself doesn't have any properties. So we want to return a header row, and this is just an object. Okay, never mind. The item type header row. Map array is definitely creating a new array, and then I can unshift the header row, I think. Or I will spread that into a resulting array. I think I won't be spreading that. So we have the data rows is map array. Oops. Map array props dot items. In here maybe we will have some kind of grouping stuff later, but right now we will just do it in here. And we have a mapper function where we just do item row item type item row. Okay, this has to be an accessor, of course. And now we can say item rows dot unshift header row. So this has to be a row the item. Right. Okay, and now I can have the header row, and now I have my rows. Not quite sure if I'm allowed to mutate this, but we will see if this is working. There we have accessor of a row of items, so now we can say rows, like that. We have columns, this is easy. Props.columns. We have a get column width. This is also easy for now. So we just say 200. Get row height. Oops. If row.type is equal, let's do a switch row.type. In case it's a header row, we will return 40, don't know. In case it's an item row, we will return 30. And export function assert never. So we're writing a function that we expect to never be called, and we will use that in a second. Should never be called, but was called with X. Let's also log it here so that we can directly log X to the console if we want to inspect that. Now we can do it like that. And now we can use this assert never in here. Default assert never row. Because now TypeScript knows that we checked all existing row types, so that TypeScript knows that in this case it's practically impossible for that from a type system point of view that we reach this row. So row has the type never, so we get no compile error. As soon as we add another row type, then this will throw an error because we are not handling that case. Now we have a get row type function. Now we need what else? Frozen areas. For now, this will only be top one for the header. Height will be props.height. Width will be props.width. And the cell will be rendered as well. So let's do that in another file. Data grid cell props. Have I defined those? Yeah, what is grid cell props? Perfect. that. T row, T column doesn't really matter now. Data grid cell, like that. Is that working? Yeah, okay. This has to, of course, return something. Now we have our grid component. This is working. Now we have the app component. And now we only need to implement the cell itself. So let's return a div for the cell. Style is props.style. So we have the row, we have the column index, row index, doesn't really matter. But now we can use another switch case. And we can do that statically because the type of a row should, in theory, never change. Because then it's a new object. Then we will create a new cell and not reuse the old cell. So we can just say function header cell and the header cell does not really need anything here, but it needs header row like that, and the column will be a column template of the item. Doesn't really matter as well. But we need that as well here. So here we can render a header cell, and then we can render our item cell. Where we can attach the base styles in the header, then we can add some column dot title, so we can render the title inside of the header. And in here, we can render the item. And this again, we can make that dynamic. Just if for some reason or another someone wants to change props column dot item. The item is props dot row. Is that correct? Yeah, that is an item row. And we need a template, which will be props.column. And now we can just add a switch case here statically. Props.row. The grid cell is called with. We just need the T item here, and we have here a grid row. This has to be renamed definitely. Like that. Now we can switch over the row type. Add a case for the header row, a header cell. Okay. This is interesting. Yeah, since I'm spreading the props. Can I do that? Yeah, I can. So this is already type safe, but I'm just spreading all props, and TypeScript is not smart enough right now. There's an open issue for that, to type check the spreaded props for this type graph that we have here. But this is not a problem. Item row, where we return the item cell. And default assert never props.row. So now we can just render our data grid cell in here. And now somewhere is still just a hello world. Data grid cell, hello cell. Generate properties of undefined. This is weird. I guess I'm not passing columns for some reason or another. Props.columns, log rows. So we have columns, we have rows, columns and rows. So the item dimensions are not there yet. That's a bit weird. So this is the first time that I'm changing the amount of rows. This is interesting. So my guess is that in here, this will be updated at another time frame than the column ranges. Now let's both use memo. We are using the rows and the getRowHeight function as a dependent. So currently I have a problem when the amount of rows is changing, but I guess. No, wait, this is happening way before. Yeah, so it's completely static, and now it's also already happening because they don't have data rows. Okay, this is the problem. The virtual grid cannot currently be rendered with only one row, because then I have an area where I render not enough items. So in here, line 60, item dimensions, because item dimensions, yeah, if we don't have, we say that we always have a frozen index. First unfrozen index. And now we don't have any elements there because We have to do it like that, from 0 to 0. The first frozen. I think this is basically the same problem. No, it's not. Okay. And now we can just where are my persons? Here, store.persons. And now I'm rendering the persons. And now I have a grid head. I have actions here. So let's remove that one. Oops. Very, very nice. And now I can handle styling on the cell level, of course. But the only thing that I want to do now, I want to try out if we can handle the column resize quite quickly, because this is actually not too hard. We just need, let's move the cells out of that file. Yeah, no, I don't think so. So we need on every cell, we need some kind of a resize handler. How is it styled here? It's just this small line. And it's looking quite cool. I think I will do that as well. So I have on the somewhere on the right side, I need something that overlaps this thing, some kind of a resize handle. And we will render this above the title, definitely. We need the CSS scope, of course. Solid data grid, CSS scope. Not called create scope. Define scope. I think I first have to fix that, and now define scope. That's a bit weird when that is not working with an auto import. So we can give the header, let's say here, div class CSS header cell resize handle. And then we need some event listeners here. But first let's style that one. Cell.css, cell.scss, of course. Yeah, I think we can just use all the same scopes. And also resize handle. And we position that absolutely at the right edge, and we are saying 100%. And just to see where it's located, background blue. And let's add a Z index of 1, which is necessary, I think. And now with, I don't know, 20 pixels maybe. Hello cell resize handle, hello cell resize handle. I didn't import the styles, of course. Okay, now we have our resize handles, perfect. But now we want to move that across the edge by using, since the width is fixed anyway, I can just say calc 0 minus 10 pixels. Never mind, minus 10 pixels. And now we are using cursor, call resize. Okay, great. Now I need a signal that tells me if I'm currently moving. So if I'm currently, so I want to be able to, when I'm touching down, then I want to listen to mouse move events. Oh no, so I can just say we have a drag start position, a drag start coordinate, drag start, set drag start equals to create signal, null as x number, y number. Let's just do it like that. Now we have our drag start. And now we are going to do on pointer, pointer down. I think pointer down is the touch equivalent. Set drag start. Oh no, that's incorrect, of course. Pointer event. So we're calling drag handle drag start, handle drag start, not client X, I think. Yeah, so let's just say set drag start x e dot client X y e dot client y. And we now need to add a global event listener. Function handle drag move. Let's call it handle drag. Document add event listener pointer move. So we get a pointer event there. Set drag position is create signal. Same thing here. X number, y number. So on drag we call set drag position, where we call that. And drag end. Set drag start undefined. Set drag position undefined. So then we just reset everything. So in here we need a pointer up and a drag end. And here we are going to remove those event listeners. Remove event listener. So now we can just, I guess, display the drag position. Let's just display the X coordinate. Okay, that's good. Now we can prevent some default stuff so that we are not selecting any text here. Perfect. Now I get the drag position. Now I need the width, current width of the column. I don't have that currently in the column template. So now I need some kind of state. Let's just do that quick and dirty for now, I think. So we will be needing some kind of a grid context, but I don't want to do that right now. So let's just for testing purposes, export const column data grid column width set data grid column width is creates signal 200. Now I can here return the data grid column width, and then I can just set the data column width here. So const move distance new width is no, this is always changing. I need an initial width when I start dragging. No, I just need the so I want to have a minimum. I think we can add that at a later point in time. But I need the initial width. So at the drag start, I need to capture the initial width so that they can then change that. I just need that. Okay. Drag start state. Set drag start state. Initial column width. Yeah, I know that a property is missing. Why can I get any autocomplete? Please give me autocomplete. This is weird. Is data grid column width only once, please? Now I have the initial column width, and now I can calculate new column width by doing drag start const start equal to drag start const end equal to const current equal to drag position, if not start or not current, return data with column width. Yeah, I think that's okay. And now I can say const diff is current minus start. I'm not quite sure why I'm getting the y values. I don't really care about those. Client y. Wait, I think we should just, at first, we should check if the diff is working correctly. Then we can return 0. And else we can return start when I move pixels to the right. Current.x minus start.x. And then I can display the diff. Yeah, this is good. This should be 200 soon. Yeah, because now I moved 200 pixels. Perfect, okay. So the diff is working. And now I can say on track. Oh no, this is not a good idea. Ah. You know what? I'm going to do like that. Let me make it just work for the ID column, I guess. No, let's take the country column. Data grade column width, or else 200. So all columns are 200 in width, except the from the country column width. And now I can resize that and say on drag is drag start dot initial column width minus diff. And now I should be able to, okay, nothing's happening. Big sad. Okay, so this is not working here. That's good. Is that even called? Yeah, move is called. That's okay. Yeah, the div is also working. Wait. Let's check the content of the new width. It's always 200. Okay. Why is that? Okay, because it's changing at the same time. What? Yeah, the initial column width. This should be okay. We remove the div, so we have to say plus, of course. Yeah, now it's working. Cool. And this is so smooth, and I can just do it in real time because nothing gets rebuilt. Let's just check that. So I can just resize that. Nothing gets rebuilt. We just do some calculations of where the cells are currently, and then directly, imperatively update the position of the elements. So now we have a very simple column resizing. We can add min values there, max values, of course, which will definitely not be a problem. But I think this is where I'm going to wrap it up for today. Okay, this is working. My virtual scrolling is working still. Let's see if this is still working when I add some frozen rows and frozen columns. Let's say left 3, bottom 5. Okay, I need to add more columns. Or I need to increase the default column width to 400. Oh, and now I have the same problem as earlier. When I don't have any data. Where was it? Here, it was here somewhere. Here, to and from. Item dimensions, here. 0. Start 0. Here as well. Okay, so now it's frozen again. So now let's increase the size of the columns again so that I can see if my frozen columns are working. So scrolling in the one direction is working, but the other is not working. Up and down is working perfectly fine. But scrolling left is weirdly enough not working. Okay, this is something that I definitely need to take a look at. Yeah, and now it's still working perfectly fine. To resize it, the scroll position is adjusting accordingly. This is a bit weird why that is not working. But this is definitely working. The resize is working, of course, so that I'm quite happy with that so far. Okay, so let's commit that as a work in progress. Start with grid infrastructure and column resizing. But we'll definitely have to clean that up a bit tomorrow and add real state to our grid that we then can provide via a context. Okay, so let's recap that for a bit. Wait, let me just, I want a bit better examples to showcase what we did today. Let's add some more columns. Like that. Yeah, now scrolling left to right works again. Weird. And now let's remove the blue background. Not here, in the cell, please. Cool, we can see that the all country columns increase at the same time. Quite cool effect. Okay, so what did we do? When we first started today, we started out with a virtualized grid that was only able to render data in a grid in one area. So when you scroll, everything scrolls. But as we said, as we defined yesterday in our goals, we definitely want to be able to have frozen rows and frozen columns. So right now, I have defined that the first row of my application should be frozen at the top. I have something like 5 rows that are frozen at the bottom. These will later be used for some kind of status row, for example, maybe, or aggregations could be another possible scenario. And we have frozen columns on the left. So when we scroll left and right, these are sticky, and we can add frozen columns to the right. Let's add an example for that. So right now we directly can say right 1. And then we have 1 frozen column on the right as well. So maybe we can add actions here that should always be visible, no matter where the user is currently scrolled at. So now we have this virtualized grid component where we can define counts of frozen columns, frozen rows, and where scrolling is still super performant. So right now I have 10,000 rows, and as you can see, the scrolling is just buttery smooth. And even if you have so many data points. And the coolest thing that I like is we can refetch the data and replace everything. So we are regenerating 10,000 elements and updating the cells in place, and don't lose any scroll position and don't lose anything in our grid while still maintaining the smooth performance. Then we started very briefly with adding this data grid component. So in the end, we want to be able to specify our grid as just a bunch of columns where we define how the column looks. So for example, the ID column is rendered by just displaying the ID, and the action columns is rendered by displaying a button element. So on the one hand, we have the columns that define the columns of our grid, and on the other hand, we just supply the items, so our persons in our case, and our grid will render itself correctly. So for tomorrow, what we have planned is we want to improve the state handling of the grid, because right now we don't have any state within the grid. That is something that we have to do. We want to place the state in a context, and we want to add some functions to this context so that you can interact with the state with these functions and not have to manually override some states, for example. If you look at our agenda, we also want to start with groups and filters, but I think we are going to invest some time in some base stylings, because right now it's just very bare bones. We'll add some paddings, for example, some base paddings that users of our component can override, of course. We didn't quite finish the column resizing, and we didn't quite finish sorting in the states, but because the virtualized grid itself was a bit more complex than I thought. but we will see if we can make up the ground. And in the end, we have some buffer in the end, in the later days, that should definitely not take us the whole 6 hours. So again, I say thank you for watching and for listening. And I hope I will see you all tomorrow. And the only thing that's left to say is have a good evening and see you tomorrow.